everyone. So we're about to go on a fascinating journey. We're going to take a generalist AI, one of those jack of all trades models that knows a little bit about everything, and we're going to turn it into a razor sharp specialist, an absolute genius in one specific field. And that really is the big question, isn't it? You've got this incredible pre-trained large language model. Its knowledge is a mile wide, but it's only an inch deep. So how do you take that and give it the deep, nuanced expertise that your project or your business actually needs? Well, the answer is a really powerful technique called fine-tuning. All right, so let's get right into it. The specialist's promise. Why would you even want to fine-tune an AI in the first place? What's the big payoff? So the core idea here is that we are absolutely not training a model from scratch. I mean, that would cost millions of dollars and take an unbelievable amount of time. No, fine-tuning is all about adaptation. It's about taking that powerful but kind of generic tool and forging it into a precision instrument that's perfectly suited for one specific job. It builds on all the knowledge the model already has. It specializes it. And the benefits here are huge. They're really tangible. Fine-tuning lets you create these completely custom solutions that speak your specific language. Whether that's complex medical terminology, dense legal jargon, or even your own company's internal slang. This, of course, leads to way higher accuracy on those niche tasks, a much better user experience, and here's the kicker, it can be incredibly cost-effective. We're talking about reducing API costs and seriously speeding up response times. But, of course, it's not all smooth sailing. This journey to create a specialist AI has its share of challenges. So let's walk through some of the most common pitfalls you're likely to run into. Just like any good hero's journey, the path is filled with a few hurdles. First, even though it's cheaper than pre-training, it can still be pretty expensive computationally. Then you've got the ever-present danger of bad data. And we have some pretty intimidating technical monsters to slay, like catastrophic forgetting, overfitting, and just making sure our new specialist model still behaves itself safely. So let's tackle this first one, because the name alone sounds pretty intense, right? Catastrophic forgetting is basically what happens when you train your AI to be a brilliant heart surgeon, but in the process, it completely forgets how to have a normal conversation. The model gets so hyper-focused on the new specialized data that it literally starts to overwrite and lose some of its original broad capabilities. The good news is we have ways to fight this. There are techniques like rehearsal, where you just occasionally mix in examples from its original training data. Or there's something called elastic weight consolidation, which is a fancy way of saying it mathematically protects the most important original knowledge from being overwritten. It's basically like reminding our brilliant surgeon to chat about the weather now and then. And this brings us to what might be the single most important point of this entire explainer. The quality of your training data is everything. Your model will only ever be as good as the data you feed it. Seriously, if you talk to seasoned pros, they'll tell you that 80 to 90% of the work in any fine-tuning project is just collecting, cleaning, and preparing the data. Garbage in, garbage out isn't just a clever saying. It is the absolute cardinal rule here. This table kind of sums up the journey for us. For every one of these big challenges, there are proven ways to tackle them. For alignment, for instance, we have techniques like reinforcement learning from human feedback, or RLHF, where people actually guide the AI towards safer answers. And to deal with that big computational expense problem, there's a really powerful tool called LoRA. And that brings us to our magic tool. Okay, if the high cost of fine-tuning is the big, scary dragon guarding the treasure, then LoRA is the enchanted sword that lets us sneak right past it. It's a technique that just makes this whole process way, way more efficient. Just look at this comparison, it tells the whole story. Full fine-tuning means updating all of the model's billions of parameters. It's super expensive, and you end up with a brand new, massive model file every time. But parameter-efficient methods, or PEFT for short, like LoRA, do something totally different. They freeze the original model and only train a tiny, tiny fraction of new parameters. We're talking less than 1%. This creates a small, portable adapter file, which makes the whole thing manageable on a single GPU. And just to put that into perspective, LoRA can reduce the number of trainable parameters by a factor of up to 10,000. No, that is not a typo. 10,000 times fewer parameters. It is an absolute game changer for making fine-tuning accessible to pretty much everyone. Okay, but fine-tuning isn't the only way to get a specialized AI. There's another really powerful technique that we need to talk about, because choosing the right tool for the job is absolutely critical. So let's look at the alternative, something called retrieval augmented generation, or RAG. So RAG works in a completely different way. Instead of changing the model's internal knowledge by training it, you just give it access to an external knowledge base. Think of it like a library of your company's documents. So when you ask a question, the system first fetches the relevant documents and hands them to the LLM as context to help it form an answer. It's kind of like giving the AI an open book test. The big takeaway here is knowing when to use which tool. You fine-tune when you want to teach the model a new skill or a specific style of talking. You use RAG when you need to give it timely, factual knowledge that changes all the time. Oh, and RAG is also really explainable. It can literally cite its sources for you, whereas fine-tuning is much more of a black box. Okay, now we need to shift gears for a minute, because this ability to specialize in AI, to give it a unique voice and a specific purpose, it unlocks a kind of power that goes way beyond just answering questions. And with that power comes a pretty profound responsibility. This quote from a recent research paper just sets the stage perfectly. When you fine-tune a model on specific and often very polarized human conversations, it learns to mimic that kind of talk with stunning accuracy. And the results can be, well, you should just see for yourself. In this one study, researchers fine-tuned an LLM on political discussions from Reddit. Then, they had a bunch of human evaluators rate comments without knowing if they came from a person or an AI. The result? The fine-tuned AI, that's labeled here as AI4, was rated as being more credible than the actual human comments. Just think about that for a second. The AI was more believable than the people it was trained to copy. And this right here is the real implication. We're not just talking about a tool to make customer service chatbots better. Fine-tuning can be used to create AI agents that are more persuasive, more provocative, and more credible than actual human beings. This is a technology of influence. So, in the end, this whole journey from a generalist AI to a genius specialist isn't just a technical challenge, it's an ethical one. It forces all of us to ask some really fundamental questions about trust, about persuasion, and about the role that AI is going to play in our society. How we choose to build and use these specialized models is going to define our digital world. The question we're left with is, how do we make sure it's a future built on responsible AI?